Hello, myself Apur Gupta. I have done this project on study of COVID-19 in Asia as instructed under the GRIP program organized by the Spark Foundation. Uh, so without any further ado, let's start. So this initially I've just imported the libraries and pre-processed the dataset. This dataset is very has a lot of attributes. I've taken certain at a time so as to make draw out logical conclusions via visualizations. Since this COVID-19 study is based on data storytelling kind of format. So the first is a combined approach between GDP per capita, comparison of GDP per capita of Human Development Index in Asian countries, in which comprises of a composite bar line chart. The second is Asia political map, which shows different macroeconomic indicators. If you just hover around the country, for example, India, it has a life expectancy of 69.6 and other cardiovascular death rates, diabetes prevalence, and washing facilities. This is of great analysis significance as it has certain physiological parameters or per se the parameters that are important for healthcare sectors like cardiovascular death rate and diabetes. At the same time, there are certain sanitation associated factors like hand washing availability of hand washing facilities, and the healthcare infrastructure related parameters like hospital beds per thousand, then the country and the demographic uh, indicator of population. Life expectancy is one of the most important macroeconomic factor as indicated by WHO and United Nations Development UNDP as well. So this is another visualization that shows country-wise progression of total reported cases of COVID-19. So country-wise progression, since we know that India is the second most affected country of the world as of now, the graph also shows the same thing. Again, the another graph, it shows that total number of reported deaths month-wise. Again, since we know that India is the most affected country in terms of number of deaths as well. However, Iran initially was there for a fair bit of time till till June, as our graph shows, and then India overtook Iran in July in number of deaths reported. Each country in this particular graph is again color coded as the legend shows us uh, with a different color. Since we know that India is the most affected country, I tried to visualize India individually. It is again it is a simple line plot with primary x-axis representing number of cases and secondary x-axis representing number of deaths. The the scale of both number of cases and number of deaths is not same. However, so just to avoid confusion, look at the numerical indicators on these graphs for that particular aspect. Then there is comparison of diabetes comorbidity. Since you know that cardiovascular diseases and diabetes are two well established comorbidities with COVID-19. I tried to visualize the prevalence of diabetes comorbidity with Asian countries. However, the graph is not that level satisfactory in this regard, because it shows that India has the highest diabetes comorbidity, but highest diabetes prevalence, but the number of cases are very high. Whereas in Saudi Arabia, the diabetes prevalence is very high, but number of reported cases is very low. What could have been a better indicator in this regard is the number of patients affected and whether they are diabetic or not. Another another indicator that I use over here is population density. Since we know that COVID-19 is a communicable disease, and that's why we follow the social distancing principle so as to prevent ourselves from getting infected from the uh, infection. I tried to conclude over here that what are the chances of what are the uh, existing number of cases in countries with higher population density. But again, population density has nothing to do with number of cases. For example, Singapore is the dense, most dense country in Asia in terms of population, but the number of cases is very less. However, India has a very less population density, still the number of cases are very high. So next up is a disk plot, which tells us the variation in the number of beds, hospital beds in a country. So this again shows a large disparity with countries having uh, 3 to 4 beds per thousand people, to countries having very low, uh, 0.01 beds per thousand people, which is a very low number. Again, since I initially talked about comorbidities, another study was done, another analytical type of graph was also made on that in this regard. This time cardiovascular death rate with total deaths. Again, it is a very, this graph can be used for making specific generalizations but not generalized conclusions, because just for example, India has very high cardiovascular death rate and also the total number of deaths, uh, in as compared to Singapore, where cardiovascular death rate is very low, that it is approximately 1/3 of what India has, and the total deaths are also very less. But again, there are certain exceptions like Uzbekistan, where cardiovascular death rate is very high but number of deaths are very low. Each bubble is again color coded as our legend shows. In last, there is a bubble visualization which shows the progression of number of cases and number of deaths in a month-wise format in every country in Asia. So if you'll just rerun it, you'll see that how number of cases progressed and how India overtook every country by the end of, I believe, May or June. By the end of June in the number of cases, and the number of cases kept on growing for India. Every country, it show, if you just over around, you'll see that how in a particular month the number of cases and number of deaths were there in that particular country. So that's all with this project. Thank you. I hope you liked it.